So now let's try and estimate some square roots of whole numbers that might not be perfect squares. What I mean by that, what if we had a number like, what is the square root of 28? So we're going to try and estimate to one decimal point what the square root of 28 is. And what we're going to do here is use this chart of all the perfect squares, so 1, 4, 9, 16, 25, 36, all the way down to 100, which was 10 by 10. We're going to think of that as a number line. So if we think of this as just a continuous stream of numbers, there's obviously numbers in between all of these perfect squares. So let's find where 28 fits. It's obviously way bigger than 1 and 4, 9 and 16. And of course you can see that it fits somewhere between 25 and 36. So if we look at just 25 and 36 and consider that as its own number line, I can see that 28 falls closer to 25. It's only 3 away from 25, and it's 8 away from 36. So I know that the estimate of the square root of 28 has to be a little bit closer to the square root of 25 than it is to the square root of 36. Now, let's just say that I had a number that fell exactly between 25 and 36, and I'll just use a straight line to show that. So if my number fell exactly between 25 and 36, you can see that the square root of that number would fall exactly between the square root of 25, which is 5, and the square root of 36, which is 6. So if I had a number exactly between, directly in the middle of 25 and 36, I know the square root would be 5.5. However, in this case, 28 is just a little bit closer to 25. So when we estimate a square root, I might say that I estimate my square root as, I don't know, maybe 5.3, we'll say, because that's just a little bit smaller than 5.5, which is the halfway mark. So if I check that with my calculator, I'm going to use Google, I can just say square root 28 and press equals, and I get 5.29. My estimate was awfully close of 5.3. So let's go back here, let's try another number, square root 40. Again, we know 40 is not a perfect square, but let's see which two perfect squares 40 falls between. So I can clearly see that 40 is somewhere between 36 and 49. So I'm going to leave it there, and let's just see how close it is to either one of those numbers. So 40 is 4 away from 36, and it's 9 away from 49. So I know, again, a little bit closer to 36, and my estimate is actually going to be fairly similar to my last estimate. So let's just see. I'm going to say, make an educated guess, somewhere around 6.3 is the square root, because I know the square root of 40 has to be greater than 6, because 36 has a square root of 6. I know it has to be less than a square root of 7, because 49 has a square root of 7. So let's go ahead and check this. If I go square root 40 equals, and I get 6.32. So again, my estimate of 6.3 was pretty close. Let's try one more. What if I tried the square to find the square root of 50? So again, I'm going to go here, and 50 falls between the perfect squares 49 and 64. It falls really, really close to 49. So basically, I'm just going to say my estimate's going to be 7.1 for the square root. So let's go ahead and check that in the Google machine. If I clear this, square root of 50, it is 7.07. That rounds to 7.1. So estimating square roots, it's actually not that hard if you think about all the perfect squares and what their square roots are on a number line.